All right, we're going to do something called, we're going to use sign pattern pictures to solve polynomial inequalities. And this is going to be a real important topic that you're going to use all the time next year when you get to calculus. So here's what I want you to understand is that a sign pattern is basically, it's directly related to the graph. So in a sense, it's like you're just graphing the x-axis, and notice what gets put on here are the zeros. So I have a 0 at -5, -2, 1, and 3. So that's what, when you have a polynomial, that's what gets graphed on the sign pattern picture. Now you're just telling me if the y values in this section, like this section here, do you see how the y values are above the x-axis? So you're going to put a little plus. Between -5 and -3, or -2 rather, those y values are negative, so it's minus. Then they go to a positive. In between this section, these y values are positive. Between 1 and 3, the y values are negative. And after 3, the y values are positive. So this right here is called the sign pattern picture for that graph. You do B, so stop the video and you try to do that. Again, what goes on the sign pattern picture are the zeros when you have a polynomial. In this section, the y values are down here, so negative. There's a plus because the y values are positive. There's another plus here between 1. I go below, so that's going to be my negative, and then I go plus again. So notice the difference, okay? Think about what happens when you have a repeated sign. A repeated sign, think about it graphically. It's bouncing off of that and is not changing. That's going to be important when we look at the next couple of things. So if this number line, let's say I didn't give you the graph this time, if I gave you the number line and it represents the x-axis, what are the zeros of the function? Well, the zeros are going to be all these places that I have dots. So I could either write it as an ordered pair, of course. So I could write them as -4, 0, 0, 0, and 3, 0. Of course, if it asked you for the zeros and you said x equals -4, 0, and 3, I would give you credit for that as well, because the zeros are -4, 0, and 3. So don't make that harder than it is. You're just looking at those dots. So if a positive sign represents where the graph is above the x-axis, and a negative sign represents where the graph is below the x-axis, identify the intervals over which this function is positive and the intervals over which it is negative. So here's the deal. If you're trying to find where the graph is positive, you're going to look at the pluses. So that's the beauty of the sign pattern picture, is like the intervals are staring at you. Where do you see your first plus? Right here. So I'll do the positive intervals over here. And I'll do the negative ones here. So assuming this goes on forever, I have -infinity to -4. And then, where's my other positive? Right here. Well, you have your low and your high, 0 to 3. Where is your function negative? Where would it be below the x-axis? Well, that's going to be where the negatives are. So that's going to be here. Now, I know you're thinking, why did you use open brackets rather than closed brackets? And when we get to the inequalities, I'll be more specific about those brackets, because these zeros are where it's on the x-axis, where it equals 0. So that's why I did not put closed, because zeros really neither positive or negative. So that's why I didn't include those. Now, if I wanted to write the equation of the polynomial in factored form, well, I certainly know, if I know my zeros, I usually like to put the x in front because it just looks better. And I have this. Now, there's two things I have to check on. Notice what we said up here. Did you notice how if you look at the graph, how the graph is going through and the sign pattern always alternated signs at all of those zeros, like it changed from positive to negative or negative to positive. Whereas when I have a repeated sign, like in this one, notice that it bounced. So if you have a repeated sign, you need to put squares on that factor. With this particular sign pattern picture, negative, positive, then I don't need any squares. But the last thing I have to look for, and I need a little more space, is not that you can get the exact value, but is this going to be a positive or negative? Because the way my graph is now, it's a positive x cubed. But what we learned from graphing, I like to look at this one furthest to the right, this guy right here. If that is a positive number, then I'm going to have a positive coefficient. If this is a negative number, then I'm going to have a negative coefficient. So I do have to put in a negative in front, and that would be my equation. Now, as far as the graph, well, I just have those things. My graph would be positive before 4, negative in between there, positive, whoa, boy, that a little shaky there, negative, and that would be my graph. Easy breezy. All right, you try the next one, stop the video, and you try number 3 all on your own. So here we go. What are the zeros? X equals -5, -2, and 3. Identify the intervals over which the function is positive and negative. So the positive ones are going to be -∞ to -5. The negatives, I am going to break it at that -2 even though they're repeated, because again, it would be equal to 0 there. So I'm going to consider that not positive. So -2 to 3, so I have 2 negatives there. And then I have one more positive from 3 to infinity. So write the equation of the function, y equals. I'll go ahead and look to see if I have to write a negative. I do not, since that is positive. I have all of my zeros, so I know that my factors look like this. But I have to be careful, because look that I have a repeated sign at what 0? At -2. Well, what factor gave me that 0 was this guy. So I have to put a squared on him, and so that is my function. And if I wanted to draw a little graph, these would be my zeros. It's a positive x to the 4th. I'm going here. I would bounce at -2, stay negative, and the graph would look like that. So what is the significance of the number line being negative on both sides at -2? That means it bounces on the graph, and you have to have a squared in equation on that factor. So here's how we're going to use this. You don't want to have to draw a graph of all these, because that just takes a really long time. Going to the sign pattern picture is so quick and easy, especially if you have the factored form. So you'll love that. So you're going to go, if it's already factored, you are going to go straight to the number line. And I usually don't draw all the divots. I do the ones I need. What would be the 0 there? If x minus 1 is the factor, then 1 is the 0. X minus 5 is the factor, then 5 is the 0. And then 3x plus 2, we'll just pop that 2 over. Think about if you had to solve this. Here's what you're really doing. I would get -2/3. I don't care if if your number line is not to scale, it doesn't matter. Now here's where I have to be more specific with the open and closed. This question is asking, where is the graph above the x-axis? Now this is just something I like to do, okay? Again, I'm not going to grade your number line, I'm going to grade your answer. If it is a greater than or less than without the equal to, I'm going to put open circles on those zeros to remind myself that I cannot include them in my answer. Okay, so I like to put on my sign pattern picture open and closed circles. So if it's just greater than, I'm not going to include those zeros, so I'm going to put open. Now, how do I get the positives and negatives? Well, you can actually do two things. Okay, this to me is the fastest. I think of it graphically. Now, I'm not going to graph it. Are you in agreement that if I multiplied this out, I would have a positive x cubed? I really don't care about the coefficient, just the fact that it's positive. And as we said before with graphing, I know the in behavior is going to be positive on the right. It matches the coefficient. Are any of these guys squared? Are any of these factors squared? No, which means the sign pattern picture is going to alternate. And once I have this, the answers are staring at me. Which answers am I going to pick? Where is my graph greater than 0? I'm going to pick the positives. So my answer is going to be open 2/3 to 1 and 5 to infinity. And that would be my answer. Now, what am I going to have to do on letter B? Well, I had a little more work, don't I? Because it's not in factored form. So I have to sit here and factor this. So you have to use your grouping. You might have to do a little bit of work. Hopefully you are a pro at factoring. So I would have x plus 3 and then x squared minus 9. Which of course x squared minus 9 factors into x minus 3 and x plus 3. So I'm going to go ahead and simplify and write that as squared. Now let's go with my sign analysis. I have -3 and 3. Again, I have open, boom, boom, because it says less than, not less than or equal to. Now here's the good thing, because really, when it's multiplied out, I could look very quickly. I have positive x cubed. So in the same way, this guy's going to be positive, but I have to be careful here. Because why? I have a factor that's squared. Okay? I have a factor that's squared. Now, which one do I repeat signs on? This factor gave me that 0. So it's going to be negative, negative. And this is a great reason why I put those open circles, because I can remember to break it at the -3. I'm picking the negatives. And so I would have to remember to break it at -3. Had it said less than or equal to, and that would be closed, I could combine and write that as a single interval. Okay? All right, let's look at C. Yay, it's factored. What are your zeros? -4, 0, because of this guy. Now be careful, what is the 0 here? Think about setting that thing equal to 0, and if you solved, you would get 3. Now on this one, because the question said less than or equal to, I'm going to put closed dots on these things. I can include them in my answer. Now let's do my sign analysis. I've got to be careful. There's the bell. Okay, so if I'm going to work it out, I have to think about if it were multiplied out. I have an x, I have an x squared, and I have a negative x. So that would be a negative x to the 4th. So my coefficient is negative, so that one's going to be negative. That factor is to the 1st power, so I'm going to alternate signs. At 0, it's to the 1st, so I'm going to alternate signs. But this guy, the 4, the x plus 4, which is the 0 at -4, is squared, so it's going to repeat. So what are my answers? Well, my answers, like I said, because it said equal to, I can include -4. So I can do one long answer of negative infinity to 0. But you got to watch out because I also have to do 3 to infinity. So don't forget that guy as well. I do want you to combine. If it's a closed circle, I do want you to combine and write your answer in the best way. Now, I just want to be very clear, okay? If you're having a hard time going, how is she getting those plus, minus? I do like the whole thinking about graphing, and since we already did that, I'm doing it that way. Technically speaking, in all these problems, I could sit here and plug in a value. In other words, I could pick a value, give me a number that's bigger than 3. So you'd say 4. Well, if I plugged in 4 for x, of course, so I'm just going to write this down, what I'm thinking in my head. If I plugged in 4 for x, that would be positive. Well, this guy's always going to be positive because you're squaring it. So don't make it harder than it is if you're plugging in. And then 3 minus 4, that's a negative. Well, if I multiply a positive, positive, and a negative, that's overall negative. And notice that's what I have here. If I wanted to test a number, if I wasn't sure, and I wanted to test a number, I could plug in 2. So let's think. X, 2 would be positive. I don't know why I just wrote 2, because I said it. So 2 would be positive. Again, anytime you square something, it's going to be positive. 3 minus 2 is positive, so overall positive, and that's what we have. So if you are unsure about a section, you do have another option and test a number. Test a number in the factored version, though, because you don't actually have to get the number. You just have to get the plus and the minus. So again, I'm just kind of going through all these. 3 minus a negative 4, that would be positive. And again, I get that. So do you see how these match up to the signs? I just think graphically is easier because we've already done that. All right, let's do our last one. We've got negative x cubed plus 11x squared minus 24x is greater than 0. Notice that I have to have 0 on one side. So I've got to make sure I have that. Now I'm going to factor a negative x out. I will have x squared minus 11x plus 24, and I would have that. I can factor one more step, x minus 3 and x minus 8. So what goes on my sign picture? I have 0, I have 3, and I have 8. I'm going to go ahead and put open circles on those so I know I don't include them in my answer. I have a negative x cubed, so I know over here I'm going to start with a negative. None of these are raised to a squared or an even power, so I know my signs are going to alternate. Now write the answers. What answers am I going to pick? The positives or the negatives? Greater than 0, so negative infinity to 0, and lost my vision there, and 3 to 8. And I would get that. And that is how you solve with sign pattern pictures. Solve polynomial inequalities with sign pattern pictures. All right, peace out.